The ocean is on fire. The maelstrom we witnessed in the Gulf of Mexico was a stark reminder of the dangers we face and the risks we accept to extract the current lifeblood of modern civilization. Many argue that this apocalyptic scene of boiling seas and searing air is just another reminder of our over-reliance on fossil fuels and our inability to live in harmony with our planet. A reliance that will ultimately result in environmental destruction, human suffering, and death. The tragic scene of boats battling desperately to control the inferno merely mimics our own political trajectory of prevarication and half measures when it comes to the threat of climate change. Others argue that such accidents are an inevitable byproduct of activities that are essential for our continued prosperity, freedom, and way of life. You might not like them, you may wish to move away from them, but they are a necessary evil, at least for now. Wherever you stand, we can all realise one thing. The ring of fire, mesmerising and terrifying as it was, must be reckoned with and understood. At 5:15 AM on Friday the 2nd of July 2021, Pemex, a state-owned petroleum company managed and operated by the Mexican government, reported a gas leak in the 12-inch submarine pipeline near its Cumalub-Zap QC satellite platform in the Campeche Sound. Cumalub-Zap, located just above the southern rim of the Gulf of Mexico, is Pemex's biggest crude oil producer, accounting for more than 40% of its nearly 1.7 million barrels of daily output. As bubbles of methane spilled from the leaking pipeline and made their way slowly but inevitably to the surface, the nearby rig attempted to isolate the leaking section from the rest of the system. Safety protocols were activated and interconnection valves in the pipeline were closed, but it was too late. Huge volumes of flammable gas had already leaked from the ailing pipeline and reached the oxygen of the surface. All they needed now was a spark. Over the next 5 hours, gas from the pipeline continued to feed a hell portal-like conflagration on the ocean's surface, while fire suppression boats fought desperately to contain the blaze and protect those aboard the nearby platform. The fire finally burned out around 10:45 AM local time. Mercifully, no injuries were reported. This is not the first major incident overseen by Pemex in recent years. In 2015, 4 workers were killed, 16 were injured, and more than 300 people had to be evacuated after an explosion on the company's Abcatun A Permanente platform in the Gulf of Mexico. In January 2013, an explosion caused by a gas buildup at the company's Mexico City headquarters killed 37 people. And in September 2012, another 30 people were killed by a natural gas plant explosion in the state of Tamaulipas. So Pemex is certainly no stranger to the danger of fossil fuel extraction and refinement. But what exactly happened on the morning of the 2nd of July 2021 in the Campeche Sound? The cause of the initial pipeline leak remains unclear. A Pemex incident report shared with Reuters claims that the turbo machinery of Cumulub-Zap's active production facilities were affected by an electrical storm and heavy rains. The wording is vague, but turbo machinery is a catch-all term that refers to systems within pipelines that can compress or decompress gases within the pipeline. Compressors are often used to pressurize and compress gas to increase gas density and flow rates within the pipeline. Gas flow rates, pressures, temperatures, and other factors are continuously monitored by electronic sensors along the pipeline, which relay data to the central computer control system. This computer system and experienced engineers can then interact with the turbo machinery in the pipeline to tweak the pipeline conditions and ensure pipeline integrity and safe operation. The incident report seems to suggest that the turbo machinery, or possibly the ability to control it remotely, was hindered by adverse weather conditions in the Gulf of Mexico. Is it possible that the pressure in the pipeline could not be appropriately monitored or regulated as a result, and built up to such a high level that it caused a leak? The Bay of Campeche is certainly no stranger to extreme weather, with the region being known as a hot breeding spot for Atlantic hurricanes, especially during the months of June and July. Indeed, in the run-up to the leak, a depression in the region spawned Tropical Storm Claudette. Pemex have committed to a root cause investigation of this incident. The initial cause of the leak will be one of the major questions that needs to be answered. Another open question is how the leaking gas ignited. For gases like natural gas or methane to ignite and burn, they must be at a concentration between the lower and upper explosive limits. When pure methane bubbled to the surface of the ocean, it would have formed pockets of 100% methane that were too rich to burn. There simply wouldn't have been enough oxygen in these methane clouds to react with the methane and sustain combustion. However, as the methane spread out into the surrounding air, mixing with oxygen, the concentration of methane would have decreased until pockets of methane and oxygen were in just the right proportion to be ignited by the smallest spark, completing the fire triangle: fuel, oxygen, and heat. What the ignition source was is currently unknown, but it's possible that the storms and electrical discharges that are common in the Gulf of Mexico might have lit the fuse. A natural ignition source naively seems likely, as no one was injured during the emergency, and potential ignition sources, right down to the negation of static electricity, are heavily regulated aboard offshore rigs. However, one thing is clear. Once ignition occurred, the fire was fed and sustained by gas leaking from the pipeline 150 meters below. So we have some potential explanations for the fire, but the timeline of events on the day in question is still very fuzzy. Why did it take so long, more than 5 hours, to bring this disaster under control? And why were control boats required to attempt to control and damp down the blaze during that delay? A standard procedure exists when tackling this kind of emergency. First, the rig control room stops gas production, and the leaking section of pipeline is isolated from the rig and the rest of the pipeline system by a series of interconnecting valves. The leaking pipeline section is then evacuated into contingency pipelines or pushed to a flare. it is burned away to prevent unwanted and uncontrolled ignition elsewhere. In this instance, Pemex claims to have closed those interconnection valves as expected. However, gas continued to leak to the surface and feed the maelstrom for more than 5 hours. How could this be? The exact reason is still unclear, but a couple of possibilities seem feasible. Perhaps Pemex was able to seal the interconnecting vents immediately, but was unable to evacuate the leaking pipeline section remotely, or was unwilling to flare off for fear of igniting the gas bubbling up near the rig. Underwater gas pipelines are maintained at extremely high pressures to pack as much gas into the pipeline as possible and ensure high flow rates. 300 meters of 12-inch diameter pipeline, maintained at a typical pressure of around 2000 psi, could have contained more than 4,000 cubic meters of natural gas under surface conditions. Of course, without knowing the exact length of the leaking pipeline section or the size of the leak, it's impossible to estimate how long gas would leak, but after consulting oil and gas experts, it's conceivable that it could have leaked for anywhere from several hours to several days. However, it's also possible that the leak was not immediately isolated, and it took a period of time to lock down. The wording of the Pemex incident report hints at this version of events. The incident was dealt with immediately when the security protocols were activated and with the accompaniment of nearby firefighting vessels. In addition, the interconnection valves in the pipeline were closed. Does this wording, the segregation of the two activities, the firefighting vessels and the interconnection valves, point to a delay in closing those valves? Did the weather interference mentioned earlier make it impossible for Pemex to remotely seal the valves and isolate the leak immediately? Was manual intervention or system maintenance required first? If the leak were only isolated after an extended delay and gas from the wider pipeline was still flowing into the leaking section, the surface fire would have had access to an almost unlimited supply of fuel. The exact shutdown and fire control strategies taken are still unclear and will be the focus of the upcoming investigation. Whichever version of events played out on the 2nd of July, one thing is clear. Fire management and control was a key concern. The fire raged less than 150 meters from the Pemex offshore platform, and yet no evacuations were required. This was partly due to the efforts of the firefighting vessels Santa Cruz Island, Campeche Bay and Bourbon Alinor and their water cannons. Efforts that have largely gone misunderstood. Many found the images of vessels desperately firing water at a fire in the sea tragic or even comical, the sea-bound equivalent of spitting on a bonfire. Of course, it's extremely difficult to extinguish a fire before it has been isolated from its fuel source. However, that was likely not the role the boats were fulfilling. The boats were attempting to contain, control and damp down the fire and keep it from spreading to the nearby rig while the fuel source was cut and the remaining fuel exhausted. Spraying water at a fire in the sea may seem ineffective, ridiculous and even laughable, but realise that it's not the seawater that is on fire, it's a layer of gas floating above the surface. When water or even water droplet mist is sprayed onto a fire, it has several positive effects. Firstly, the heat of the fire is transferred to water droplets, which evaporate and carry heat away from the fire, damping it down and slowing the burn. Water has an extremely high heat capacity. It can absorb a lot of heat energy without its temperature rising and the water evaporating. This is why if you put out a bucket of water on a hot day, it will warm up for sure, but it's unlikely to boil and scald you. However, if you put your foot onto the asphalt around the bucket, which has been resting under the same scorching sun, you're very likely to get a burn. Much less energy is required to raise the temperature of the asphalt. It has a lower heat capacity. Water jets or mists can therefore remove huge quantities of heat from a fire, dull the burn, and reduce the chance of further ignition, perhaps closer to the rig. It's clear that the seawater surrounding the fire is absorbing heat away from the fire by conduction down into the ocean. But it makes sense to rob the fire of heat from all angles, not just from below. So firing a water mist can still have highly beneficial effects. Water mists also displace oxygen and methane in the vicinity of the fire and replace them with a higher concentration of water vapour. This starves the fire of oxygen and again damps down the flames. Indeed, water mist fire control systems are incredibly common and find significant use in ship-based and naval applications. It's also possible that the water jets were not simply water, but contained a fire suppressant chemical or powder. This is unconfirmed. However, reports from Pemex also suggest that company workers used nitrogen to control the fire. Nitrogen is an incredibly unreactive gas, and delivering it into the vicinity of a fire to displace oxygen would certainly help to contain a burn. Indeed, nitrogen is frequently used in building-wide fire suppression systems and fire extinguishers, as it is inert, non-toxic to humans, and abundant in the atmosphere. It's unclear how nitrogen was used as a fire suppressant in this case. It's possible that the fire control boats were releasing nitrogen gas, but it seems unlikely that the boats would have had huge stores of bottled nitrogen gas. However, inert nitrogen is commonly used in the oil and gas industry to flush and purge pipelines without risking ignition. Is it possible that Pemex flushed the leaking pipeline section with nitrogen gas to purge the remaining gas and also allow fire suppressing nitrogen to bubble to the surface of the ocean and tackle the fire from below? Such a strategy would be incredibly inventive and makes sense from a chemistry perspective. What should be clear is the fact that the boats were not just there to look busy and endure the wrath of social media. In an emergency situation like this, it's all hands to the pump, quite literally. So, while we can make educated guesses and scientific inferences about what might have happened on that morning in the Kempesh Sound, many questions remain unanswered. What caused the initial leak? What ignited the gas? Why did the fireball take so long to be brought under control? Answers to these questions must be the focus of the upcoming investigation. But the disaster raises wider questions. Are incidents like this a reality that we should simply accept and learn to deal with? Or are they yet another reminder of our need to shake a dependency on fossil fuels and the bounty of the deep earth? We might have got lucky on this occasion. Mercifully, no one was hurt. And while the fire facilitated a social media frenzy, it likely contained a lot of the environmental damage by consuming much of the leaking methane and other hydrocarbons. Next time, we might not be so lucky.